Topic is light reflection and refraction. Hello, hi everyone. Welcome to the Student the Brand. So, light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So, I am taking the plane mirror. This is a plane mirror. Plane mirror. So, plane mirror I am considering. Okay. The light ray which is incidenting on it, that is incident ray. So, I am taking this incident ray. The light ray which is reflecting back is called reflector ray, incident ray, and reflected ray, So incident ray, reflected ray, the light ray which is perpendicular to the surface, that is called normal line. The light ray which is perpendicular to the surface, that is called normal line. So here I am considering this is a normal line. The light ray which is perpendicular to the surface is called normal line. Normal. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay. So, and the light ray which is undeviated, so which is not deviating through the surface, it will be the incident. It is a direction of the initial direction of the incident ray. So here I am taking this is a plane mirror. Plane mirror. So here I am taking this extended incident ray or initial direction of the incident ray. Okay. So now you can take. So the angle between reflected ray and initial direction of the incident ray is called angle of deviation. So once again, the angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line or initial direction of the incident ray is called angle of deviation. Okay. So now we will discuss so this is a linear angle. Linear angle is 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So from laws of reflection we can take angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection, first point. Coming to laws of reflection. Laws of reflection. laws of reflection. First one is angle of incidence is equal to angle of reflection. Second point is incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Okay. So from this laws of reflection, angle of incident is equal to angle of reflection. So we can take like this: angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So in case of angle of incidence, if you substitute in the place of angle of incident, if you substitute angle of reflection, you'll get this formula. Angle D equal to 180 minus 2 angle of reflection. So angle D equal to, so angle of deviation equal to 180 minus 2 angle of incidence. Okay. So now we can take, that is about angle of deviation. So this is about loss of reflection. Okay. So the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. The bouncing back of the light from the reflecting surface is called a reflection of light. The light which is incidenting on the surface is called incident ray. The light which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface, that is called normal line. The angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Okay, so this is about reflection of light. Okay, now so we'll discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection we'll discuss. Regular reflection and irregular reflection. So I am taking the plane surface like this. So these are the incident light rays. So 1, 2, 3. Okay, so these are the incident light rays. These are parallel to each other. Then reflector light rays are also parallel to each other. So incident beam, incident parallel beam I can take, parallel beam. So this is also reflected parallel beam. Okay, so here we can take, so whatever the light rays are incidenting, those light rays are parallel to each other. Then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. This type of reflection is called regular reflection. Regular reflection. Coming to irregular reflection. Irregular reflection. Irregular or diffused reflection. Irregular reflection or diffused reflection. Mhm. So incident beam is parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection, or also we can say diffuse reflection. Irregular reflection or diffuse reflection. Okay, diffuse reflection. So this is about regular reflection and irregular reflection. Regular reflection takes place on a smooth surface. Regular reflection takes place on smooth surface, still water and plain surface. Irregular reflection takes place on we can take wall and a rough surface. Okay, so that's enough. That is about regular reflection and irregular reflection. So coming to the nature of the image, so we'll discuss about nature of the image. Okay, so let's start. So nature of the image we'll discuss. So I'm taking the plane mirror. So this is a plane mirror. So this is a object. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. How many light rays? Minimum 2 light rays are required to form the image of the object. Okay. So I am taking 2 light rays. One light ray I am taking like this. So another light ray I am taking like this. So here also we can consider, and like this also we can take. If you are extending these light rays, those light rays will meet at one point. So this is AB, and this one is A dash and B dash. AB and A dash, B dash. Now, object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. So here you can take. First point is object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. At the same time, object distance is equal to image distance, and the height of the object is equal to height of the image. And also it shows lateral inversion. Lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Okay. So these are the lateral inversion phenomena. Once again, so object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance, the distance between objects. So this the distance between object to mirror is equal to object distance. The distance between mirror to image, this is a mirror image, so image distance. Object distance is equal to image distance. Height of the object is equal to height of the image, and also shows lateral inversion. So what is lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Okay. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called a lateral inversion. This mirror image is called lateral inversion. I hope it is very clear. So this is about lateral inversion. Okay, so these are the points. Once again, check here. Object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object is equal to height of the image, and also shows lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Okay, next. So we'll discuss. So that is about nature of the image. So now we will discuss about nature of the image formed by the plane mirror. Now we will discuss about concave mirror and convex mirror. So there are two types of mirrors. Depends on reflection of light. If reflection takes place inward, that is called concave mirror. Reflection takes place outward, that is called convex mirror. Okay, so I'm taking here, you can observe. So this is a concave mirror. Concave mirror. So reflection takes place inward. Reflection takes place inward. Okay, so I'm taking here. And here one more I'm taking. So this is the convex mirror. This is called concave mirror. Concave mirror. And this one is convex mirror. Convex mirror. Concave mirror and convex mirror. Concave mirror, so when light rays incident on it, so after reflection those light rays will meet at one point on the principal axis. Okay, so like that. Light rays will be converged. Here, light rays will be diverged. Means after reflection, those light rays will move away from the principal axis. So now we have observed. So by seeing the diagram, we can conclude that. So after reflection, the light rays are moving towards the principal axis. Right? After reflection, light rays are moving towards the principal axis. Here you can observe, after reflection, light rays are moving away from the principal axis. Okay, so now you can observe here. Here you can observe, after reflection, those light rays, light rays are meeting at one point on the principal axis. Okay, so these light rays are converged and meeting at one point. Here, after reflection, light rays are moving away from the principal axis. These light rays are diverging from the mirror. So concave mirror and convex mirror. Concave mirror and convex mirror. Okay, so this is about concave and convex. Next one, so we will discuss about terms related to spherical mirror. So after terms related to spherical mirror, so we will discuss about ray rules. ray rules of concave mirror and convex mirror. After that, image formations of concave mirror and convex mirror. Okay, so we'll discuss now. So now terms related to spherical mirror we'll discuss. Terms related to spherical mirror. So I'm taking the concave mirror. Is a part of the sphere. Spherical mirror, which is a part of the sphere. The center point of the center of the sphere in which mirror is a part. Okay, the center of the sphere in which mirror is a part is called center of curvature. And the second one, so here this midpoint of the mirror is called pole, and the line joining of center of curvature and pole is called principal axis. Line joining of principal axis. Line joining of center of curvature and pole. Line joining of center of curvature and pole is called principal axis. The distance between center of curvature to pole is called radius of curvature. This is called radius of curvature. Radius of curvature. So actually I'm taking, so I took the concave mirror. So whose reflection takes place inward. So concave mirror whose reflection takes place inward. Okay. Now, so you can observe after reflection all light rays will meet at one point on the principal axis. So after reflection the light rays are meeting at one point. Here you can observe. So this is focus. Fifth one, principal focus. Principal focus. Principal focus. F. And the sixth one, the distance between focus to pole is called focal length. So the distance between focus to pole is called focal length. Focal length. Okay. So center of curvature, pole, principal axis, radius of curvature, principal focus, focal length, and the width of the mirror is called aperture. Width of the mirror is called aperture. So I am taking this is M dash, M and M dash. Okay. So I hope it is very clear. Just check once. Once again, center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. Line joining of center curvature and pole is called principal axis. So the distance between center curvature and pole is called radius of curvature. And after reflection, all light rays will meet at one point on the principal axis, that is called principal focus. The distance between focus to pole is called focal length, and the width of the mirror is called aperture. Width of the mirror is called aperture. So these are the terms related to spherical mirror. Now I will explain about okay. So now we will discuss about ray rules of concave mirror. Okay. So ray rules of concave mirror and convex mirror will discuss. Concave mirror. Here convex mirror. So concave mirror and convex mirror. Concave mirror. Okay. So here you can observe. First point is, so pole, focus, center of curvature. Pole, focus and center of curvature. I am taking a concave mirror. So here one light ray I am taking. After reflection, the light ray passes through focus. Second one, so pole, focus, center of curvature, light ray is passing through focus. After reflection, moves towards infinity. Coming to third one, pole, focus, center of curvature. Light ray is passing through center of curvature. After reflection, so it retraces its original path. And coming to the fourth one, so pole, focus, center of curvature. So light is incidenting at the pole. It reflects back. So these are the ray rules of concave mirror. Ray rules of concave mirror. Now coming to ray rules of convex mirror. So we'll discuss. Pole, focus, center of curvature. Light rays coming from infinity after reflection passes through focus. So it passes through focus. Okay. Now, second one, pole, focus, center of curvature. Pole, focus and center of curvature. Light rays passing through focus. After passing through, okay. So after reflection, it moves towards infinity. And coming to third one, so pole, focus, center of curvature, pole, focus and center of curvature. So light ray is passing through center of curvature. After reflection, it retraces its original path. And coming to the next one, fourth one. So pole, focus, and center of curvature. Pole, focus and center of curvature. Light ray is incidenting at the pole. It reflects back. Okay. So these are the ray rules. Just check once. Okay. So we'll discuss about image formations later. Just after 5 minutes. Check once. Okay, so I hope it is very clear. Just check once. Okay, I hope it is very clear. So ray rules and image formations. Now so image formations we'll discuss. Concave mirror and convex mirror. Concave mirror. So concave mirror image formations. So I'm taking here pole, focus, center of curvature, pole, focus and center of curvature. Object is at infinity. Object is at infinity. Okay, so I'm taking object. It is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I'm taking one light ray like this and one more light ray. Okay. So one light ray I'm taking. So after that one more light ray. So object is at infinity. Image is forming at focus. So object is at infinity. Image is forming at focus here. Like this. F. So image is formed at F. Nature of the image is real and inverted. Nature of the image is real and inverted, and size of the image is so object is at infinity. Image is forming at focus. Okay, so nature of the image is real and inverted, and size of the image is highly diminished. Highly diminished. So first one, coming to the second one. So pole, focus, center of curvature, pole, focus and center of curvature. Okay. So now object is placed beyond center of curvature. One light ray I am taking like this, another light ray it passes through focus. One more light ray is okay. So here the image is formed between C and F. Object is placed beyond C. Image is forming between C and F. Nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is diminished. Coming to the third one. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at C. So image also will form at C. One light I am taking like this. So another light ray it will be meeting at focus. So object at C, image also will form at C. Nature of the image is real and inverted. Nature of the image is real and inverted, and size of the image is same size. Coming to fourth one. Object is placed. So this is a pole. So pole, focus, center of curvature. Object is placed between C and F. One light I am taking like this. So object is placed between C and F. Image is forming beyond C. Nature of the image is real and inverted. And the size of the image is enlarged. Compared to the object, image size is increased, enlarged. Okay. So this is about concave mirror. Concave mirror image formations 1, 2, 3, 4. So two more are there. So next one is at F. Another one is between F and P. So we'll discuss. So next one is at F. So pole, focus, center of curvature, object is placed at F. One light ray I am taking, so it passes like this. Another light ray I am taking like this, so it will meet. Object is at F, image is forming at infinity, nature of the image is real and inverted, and the size of the image is highly enlarged. Highly enlarged. Next one, so this is the fifth one. Coming to 6. So pole, focus, center of curvature, object is placed between F and P. One light ray I am taking like this, it passes through focus. Another light ray is incidenting at the pole, it reflects. So we are extending these light rays. These light rays are meeting here. Okay. Object is placed between F and P. Image is forming behind the mirror. Behind the mirror. Nature of the image is real, virtual and erect. Virtual, erect, and size of the image is virtual and erect. Size of the image is enlarged. Size of the image is enlarged. Okay. So check once here. Next one, sign conventions. So sign conventions here. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance positive along the instant race. Distance negative opposite to instant race. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So here, now we are talking about new Cartesian sign conventions. I'm taking the play. So spherical mirror here is like this. This is a spherical mirror. So pole I am taking. This is the pole. Focus and center of curvature. Pole, focus and center of curvature. Okay. Now all measurements will be taken from the pole. First point. Second point, in the direction of incident ray is positive. Opposite to incident ray is negative. Above the principal axis positive and below the principal axis negative. Once again, all measurements will be taken from the pole. In the direction of incident ray is positive. Opposite to incident ray is negative. Above the principal axis positive. Below the principal axis negative. So these are the sign conventions. Okay. So magnification. Coming to the magnification, if you discuss. So m equal to minus v by u, or we can take height of the image by height of the object. The ratio of size of the image by size of the object, or height of the image by height of the object. M equal to minus v by u, that is nothing but mirror magnification. And coming to the mirror formula, 1 by f equal to 1 by v plus 1 by u. This is a mirror formula. And you can so take it for length. It will be 1 by f equal to 1 by v minus 1 by u. And magnification equal to height of the image by height of the object plus will get. Okay. So that is for lens. This is for mirror. And so this is about spherical mirrors. Okay. So now we will discuss about spherical lenses. So after small break. So thank you so much for joining and attending and listening my class. So if you like the content, if you like the channel, do like, share and subscribe to Student Development. Thank you.